So I titled this talk The Wild West, East, North, and South, because a lot of times when we're discussing distributed applications, we get really bogged down in the technologies that we're using and the CI/CD pipeline and building microservices and containerizing these services. And then we really lose sight of what we're actually trying to achieve or potentially why we're trying to achieve it. So, we could speak ad nauseum about any number of technologies in building these geo-distributed applications, but I sort of wanted to just distill this down into a little bit of the theory behind why we actually might need these applications in the first place. And then we can dive into some practical examples of how I'm developing these applications. So I'm just briefly going to introduce myself. My name is Brett Hoyer. I'm based out of San Francisco, but grew up in the Philadelphia area. And I don't have the most traditional path to starting a career in software. I thought that I was going to, make it big on Wall Street at one point, and then wanted to become a college professor. And then after university, I just decided that I should learn how to code and that it would give me a good foundation for being able to sort of, live wherever I want and potentially start my own business someday. And that's what drew me to software originally. I wound up getting a little bit of a foundation in my learning and moved out to San Francisco and took some engineering courses and eventually got a job as a front-end engineer. And I was a front-end engineer for about 9 to 10 years in a number of different industries. So I started in music streaming, and then I worked for a big data analytics startup before moving my way to work at Oracle on the IoT team there. So building, data-intensive applications for production monitoring, asset monitoring, monitoring fleets of trucks, all sorts of IoT applications. But now I'm in a completely different role where I'm actually developing distributed applications at a distributed database company. The company is called YugabyteDB. And this company is developing a distributed SQL database. So I'm sure many of you have heard of MongoDB or Google Spanner. There are a number of distributed databases, but this class of distributed SQL databases is a little bit newer, but has a lot of the same benefits of those distributed databases while also having the underlying SQL syntax that we've all been using for decades. So before we dive into distributed applications, I just wanted to distill down applications at their core. I know we're all developers here. This isn't exactly groundbreaking information to any of you, but like I was saying at the opening, I feel like we often are overcomplicating the way that we view the architectures of our applications. At the core, our applications are often just a presentation layer, an intermediary, server layer, and a data layer. Of course, we can have any number of caching layers, reverse proxies, load balancers, anything in between, messaging systems like we discussed in the last meetup. But these are the three core layers that I'm going to use as the foundation of this talk, just to keep things simple and not get too much off of the rails, so to speak. So the question that we're really looking to answer in this talk is, do we really need distributed applications? And for many applications, the answer is potentially no. if you're building an application that doesn't have certain latency latency or availability constraints, or doesn't need to meet any regulatory constraints for data protection, data privacy, you might get away with just building a single region application that, has some faults, but it's getting the job done, and it's not serving like a mission critical application. But in order to discuss this further, the whole premise of this talk, I'm going to be working through the idea of a fictitious online retailer. Let's say that I've started thinking I want to reach retirement sooner, so I've decided that I'm going to spin up a service selling print-on-demand T-shirts. I'm sure we've all seen many of these services nowadays where you can create your own design and get T-shirts manufactured very easily. So that's the premise of this talk. As you can see here in the legend, the phone will be our UI, the server icon will be the server, and the DB icon will be a DB node for a distributed database. So in order to answer this question, do we need distributed applications? We will be discussing this with regards to latency, availability, and data residency most specifically. So what are the problems with traditional architecture? Let's get into it a little bit. So let's say that this T-shirt business that I'm starting is beginning regionally, but as we're growing, and maybe we're tossing up some Facebook ads trying to get additional traffic, maybe we actually have we call this a happy problem, where we're actually serving demand globally. So what are the problems that will arise with this infrastructure? Well, it's fairly obvious to all of us, I would assume, that we are now incurring a pretty high latency cost. In this example, we have a customer who's browsing our application from London, and our infrastructure is deployed to the western region of the United States. So a general rule of thumb, according to GCP, is that for every 100 kilometers, you can expect about 1.5 to 2 milliseconds of latency between the two locations. So how do we fix this problem? Of course, we are serving up a pretty bad user experience to our users, amongst other issues that we'll be running into. So one natural inclination would be to, provision additional infrastructure so that our clients can connect to our application services more regionally, closer to their local location. And this is absolutely correct. Of course, for a number of reasons, we're balancing the load across multiple machines. We're reducing latency. But one thing that we often fail to recognize with our application stacks is that we're still connecting from all of these services to a single database node. Traditionally, applications will combat this maybe by having replica nodes that are serving reads or shards of their database. There are various strategies, but these are often self-managed solutions that become kind of engineering nightmares at times. So what my company and various other distributed databases allow you to do is to actually distribute your database in various modes, depending on the needs of your application, so that we are fully able to distribute our applications across the entire stack, not just our application tier, but also our data tier as well. So we've handled latency. We're able to serve our reads and writes more regionally by distributing our application and our database. But what about availability? So we want to reduce the amount of downtime that we have if our application services go down. That's what availability is at its core. So let's imagine that our infrastructure is back only being deployed to US West, but we're experiencing a lightning storm, and this lightning storm takes out an availability zone. It takes out a full data center in Google's cloud infrastructure. Let's say that that's where we're deployed. Well, now if our application services are deployed in a different availability zone, we might still have a functioning application. The lights might still be on, but at the end of the day, our application isn't, our application is essentially down because our database has gone down. That's also not to say that our server isn't also going to go down as a result of this. And although we rely on the infrastructure of AWS, Azure, GCP, statistics show that data centers do go down fairly regularly, sometimes for as much as a day. I know when the grid was out in Texas, a number of applications were down for many hours, if not a day or more. So this is a real issue that, for maybe my little t-shirt business isn't critical, but imagine that you're Walmart or Charles Schwab or Wells Fargo. You need to build a system that's resilient enough to withstand these outages. So naturally, we want to be deploying our infrastructure in multiple zones, hopefully multiple regions. And for some of these huge global retailers or financial institutions, potentially even on multiple cloud providers as well, so that we're covering all of our bases of availability for our services. And there are multiple strategies to be able to do this, to detect downtime in our services and easily reroute traffic to other services in other regions. I'm sure many of you are familiar with Kubernetes. I'll be touching on that briefly later, but there are a number of ways of building in this resiliency into your applications. Lastly, this one I'm just going to touch on briefly because many of you will probably never have to deal with this in any of your applications that you develop in your career. But for some applications, we need to take into account data residency. For instance, GDPR and the IT Act, Information Technology Act in India, there are laws that govern how we protect user data in the EU and in India. And for some types of information, financial information, medical information, data actually needs to be stored within the country where that user resides. So in our previous example, where we were displaying high latency of users connecting to a database in the United States, for certain classes of application, that architecture simply isn't allowed by law because your user's data literally needs to reside within the country where your user base lives. So that's another reason that a distributed database or a global application would be just simply a requirement for the application that you're developing. So now that we've gotten through some of the reasons why we might need to distribute our applications, I just wanted to discuss some of the tools that I have used in developing some applications. I'm sure many of these, some of you are familiar with, at least. Oddly enough, I only knew of some of these tools anecdotally, I guess, or based on reference. For the majority of my career, I was building cool data visualizations dynamic like dashboard UIs, but I was never really tasked with solving some of these problems of distributing and deploying these applications and such. So because my day-to-day is essentially developing cool applications to showcase the functionality of YugabyteDB, this distributed SQL database, I've been able to use many of these tools to create some cool demo applications, one of which I hope to show you today. So these tools are Kubernetes for managing containerized applications, and I'll go through some of the benefits of Kubernetes. I couldn't possibly get through all of them. I mean, it's just such an unbelievable tool. I would definitely recommend checking it out if you haven't yet. Then there's distributed SQL, but also, there's NoSQL databases, Cassandra, HBase, Google Spanner. There's so many different. CockroachDB is another distributed SQL database that's one of the leading competitors of YugabyteDB. So there are all sorts of distributed databases based on the needs of your application, what syntax you wish to use, and so forth. And then I'm going to talk, and I'm actually going to demo, if time permits, actually provisioning infrastructure using Terraform, and then deploying and running an application using Ansible. You can do both of these tasks via Terraform, but they actually explicitly state in their documentation that they recommend using other tools for your application code deployment. Any questions, or should I just surge forward? Good to go?
Yeah,
okay.
All good.
So let's see. So in speaking about Kubernetes, I don't know how many of you are familiar, but a lot of our distributed applications wind up feeling like this big ball of holiday lights that you dig out from a crate in your garage around Christmas time, and you go to put them up in your house, and it's just a complete mess. You're trying to figure out how everything is networked, how you can manage failures and spin up new instances when an application node goes down and such. So Kubernetes really wrangles all of that, and it untangles all of this mess for you. Via configuration file, you can use Kubernetes to deploy containerized applications. Maybe you're using Docker to create images of your application, and you can very easily scale up and down your application. So let's say for our retail example that we've been working through, that on Black Friday or around the holidays, we're receiving a ton of traffic. But normally we don't need a whole lot of servers, but around the holidays, we're selling a bunch of merchandise. Kubernetes can be configured to very easily scale up or down your deployment, either vertically or horizontally, to service more users. And it can be used to load balance requests between all of these instances, so that we're achieving this high availability that we need in this application. And we can network this very flexibly. Even globally, we can set up Kubernetes to with a global load balancer to have ingress controllers that are load balancing regionally, or we can use a service mesh, which is another tool that can be used in conjunction with Kubernetes. Istio actually works with technologies outside of Kubernetes as well, but if you need really complex networking of these applications, Istio provides a ton of bells and whistles, beyond the already incredible framework that Kubernetes has set forth for us. So this one is obvious, so we can scroll through this pretty quickly, but some people who haven't ever had to deploy infrastructure or care about these things might not even consider scaling vertically versus scaling horizontally. With regards to our data tier, databases like Oracle or DB2 or a lot of traditional SQL databases are scaling vertically, typically ramping up your hardware in order to achieve better results for your database. But now, as we've discussed, there are all new classes of databases that allow you to scale horizontally, to shard your data out to a number of nodes to achieve better latency and availability for your database. So we've been over a number of these things, but by scaling horizontally, we have better availability, protects against outages, data residency, native replication. So that's something that we haven't yet discussed, but a lot of application developers, or I guess even farther into the stack, working predominantly with the database, have to do a bunch of complicated engineering work to replicate their data, to shard their data out to multiple different copies of the database, to have failover to these nodes, this and that. But modern databases allow you to just not have to worry about that anymore as a developer, and just allow these managed database services to shard your data and have all this failover for you by default out of the box. So that is a very nice feature of saving your engineers a lot of time at potentially a little bit more of a financial cost, but potentially not when you consider the cost of developers. And then there are multiple configuration options of these databases. Like you can have a distributed deployment where the copies of your data are being synchronously replicated, meaning, a write to the database is going to take more time, because until all of the database nodes reach a consensus that they've been updated with the fresh copy of the database, or the latest write of the database, that write will not actually be executed, which might be fine for certain applications. But you can also tune these databases to replicate asynchronously. You can have read replicas in faraway regions that are just serving reads but not writes. You can geo-partition these databases so that certain users in different regions are only interacting with certain database nodes for data residency purposes. There are a number of ways of tuning these databases to the needs of your application. And then this slide is really just signifying that although I've been using just a single database icon, single node in some of these diagrams that I've been showing, we actually want a cluster of nodes in each of our regions if we can have that infrastructure, because we would like to be able to have multiple availability zones such that if one were to go down, we can still serve traffic to another zone in that region. Okay, and then I will quickly get through Terraform and Ansible and show a quick demo. So Terraform is a tool that can be used to deploy your infrastructure. So we were talking about Kubernetes and using Kubernetes as a container orchestrator and handling all of that networking and such. But what if we just want to spin up some VMs or or set up a network, a VPC network in AWS, GCP, or any number of things. Terraform is almost an equally powerful tool for spinning up your infrastructure. And you do this via configuration files, and Terraform is managing the state of this infrastructure provisioning, so it can actually keep track of the diffs in what you have provisioned, such that when your configuration changes, it only needs to tweak minor things in your cloud provider and deploy the infrastructure. So this eliminates the need for you to click around in GCP or AWS and potentially forget to set some settings somewhere, or someone in your company who managed the provisioning of your application found another job, and you have that one, this is probably relatable to some people, you have that one knowledge sharing meeting, but the person only gives you 25% of the information that you need on your application. Terraform and Ansible provide ways where the code is sort of self-documenting. That's something that I really like about it. You can very easily see the declarative language that are in these scripts, and we will go over them shortly. And I'll show you the benefits of that in my deployment that I have to show you. So Ansible works right in line with Terraform. Terraform is great for provisioning our infrastructure, and Ansible is great for deploying our code and running our application services. So the way that I'm using these tools is Terraform is spinning up a network for me. It's spinning up all of my application services, providing me IP addresses in output variables. And then I can use Ansible to deploy my Node.js and Nginx application code to these services, to these machines, these VMs. So Ansible is used to set up these machines, install dependencies that you might need for whatever type of machine that you are deploying. You can provision or deploy your application code, and you can also start up these services. So in my case, starting up an Nginx server, as well as multiple PM2 Node.js processes on microservices, I guess, application instances, as I call them. And in Ansible, you set an inventory file with all of your IP addresses of the machines that you need to interact with. And then you set a playbook that can be modularized and shared across teams. So a playbook is essentially a set of steps that need to be executed on all of these machines that we're interacting with. So I got through all of that as quickly as I could. And now I have time for a little demonstration. So before we jump into the code, I just thought it might be good to give a little lay of the land here. So the application that I've built is a little, it's a demo application. It's the best way that I could think to show traffic originating in different regions of the world in the simplest way possible. So by connecting to this application through an Nginx server, this Nginx server serves both the UI of the application as well as serving as a reverse proxy server to multiple application instances that are deployed in 3 regions around the world, in Los Angeles, London, and Mumbai. So I'm able to actually show traffic that is originating from these regions to their local DB nodes. This is a geo-partitioned cluster that I have provisioned in the cloud. So why don't I cut over to my code and show that. Let's see. So this is the application that I'm going to be showing. Trying to get back to my. Okay, still with me, Yuri? So I want to show my Terraform configuration and my Ansible configuration, and then we will actually run the scripts. I will run through this as quickly as possible because the details are not even necessarily that important. We will get the point here, but Terraform at its core consists of a main file, which sort of is a parallel to the Ansible playbook, and this file is showing all of the resources that I'm provisioning in GCP. So I'm providing it with a credentials file, which is essentially giving me access to interact with this project that I've set up in GCP. I've created a network with a particular name, so a VPC network, a private network in GCP. And I'm looping over some variables. I'll show my variables file to deploy multiple instances in GCP, as well as an Nginx instance, which is going to reside in US West 1, so in the Los Angeles area. Let's see here. So I am setting up SSH keys on these machines so that I can SSH and copy code to these machines. That's something that can be done via Ansible. I'm setting a static IP address on my Nginx instance, and I'm allowing my instances to have certain networking capabilities, being able to tag instances such that they can only be accessed via certain IP addresses. Like, in a real application, we don't exactly want to be opening our application to, every address on the internet. That generally is not what we're looking to do. But we can set variables here. I'm setting internal IP addresses for these machines. And as I mentioned, I am passing a key file, which allows me to provision this infrastructure. An outputs file is just used to output the IP addresses of the machines that are being provisioned. So then I can use those IP addresses in Ansible to deploy my application code. But I've commented out my public IP address for this so that no one tries to hack me. Not that I don't trust all of you.
I have a question.
Okay.
This question goes back to schema. It means like you're trying to deploy like 3 different regions, and one of them a little bit different because it has Nginx that is going to be responsible for like geo-distribution. Is it correct?
Yeah. So I'm deploying a database and application services to three regions, and then an Nginx server, which in theory could be deployed anywhere. In a real world setup, we would probably have multiple Nginx servers or other types of servers around the world, so that we're serving traffic local to those regions, like a global load balancer or something.
I see.
But the way that I'm using Nginx is as a way that, based on certain API paths, I'm able to target different application instances globally, such that we're interacting with the local database nodes. And that's a way of sort of mocking traffic coming from those regions around the globe. So that's
Thanks a lot.
how that's the reason for the reverse proxy there. It's sort of just a demo application, but it just serves to demonstrate this purpose. So as I was mentioning, like via that Terraform configuration, we are able to do a diff and view the plan from this application. So I've already initialized this deployment, and I actually have it running in GCP. So if we run our Terraform plan, we can see that we're running through various steps. We're setting up an application firewall, this and that, all of the things that we had mentioned. But the Terraform configuration is matching what we already have deployed. So Terraform is able to keep a history of what we've deployed, as I mentioned. If you were working on a team with multiple DevOps or other engineers handling your provisioning, then this Terraform state would actually be put in a repository that could be accessed from multiple machines. I'm just running this from my local file system, and that's perfectly okay for the time being. And if we were to do a Terraform apply, which actually goes to provision our infrastructure, then we're going to see that we have our outputs of our internal IP addresses for our application instances. I've commented out our Nginx server because that is the only server that is meant to be publicly accessible from the internet, and I didn't want to expose that just in this demonstration. So that is how Terraform works. And if I can find my, trying to find my browser again, but I've lost it here. Here we go. Can you see my GCP right now?
Yeah, I can see it.
Yeah, so this is the infrastructure that has actually been deployed via that Terraform configuration. It's just a very simple configuration, but just via that Terraform config without having to do anything in here outside of setting up a project and downloading my configuration, my credentials. I was able to deploy all of the infrastructure required to run this application. It's also worth mentioning that there is a Terraform provider for YugabyteDB, and I presume other managed database products as well. So the database backing the application that I'm developing, I just deployed manually on YugabyteDB's cloud in the same three regions where our application infrastructure has been deployed. So getting back to the code quickly, I have our infrastructure in place, and now using the outputs that we've gotten from Terraform, I'm able to actually deploy the code for this application to these machines. So using a simple configuration with hosts defined, these are just internal hosts. These aren't accessible to the internet. I'm able to pass various environment variables to these machines. I'm able to use my Nginx host as a jump host, meaning that I can proxy through this host to the internal IP addresses of my services to to deploy code to them. And by using this very simple inventory file, I can run a playbook to actually install an Nginx server. I can copy my Nginx configuration to this machine. I can copy my React.js application that I've developed to this machine. And when I've done so, I can actually restart the Nginx server and start interacting with my UI. Just the same, I can update the Ubuntu machines that I've deployed for my application services and install Node.js, copy the certificate file that I need to interact with my database. And then I can start the Node.js process, stop and restart the Node.js process that is backing all of these microservices for the application. So you can see that, like, in a very declarative way, we're able to deploy our application code, install all of the dependencies to run the application, and our configuration here is sort of documenting itself. You can very easily see what each step is doing. I've just been working on this for the past couple days, or I was working on it over the weekend, actually. So some of these steps will actually be broken out into a different playbook altogether, and we can modularize these playbooks to be very robust. I actually want to write a script that will automatically take my output IP addresses from Terraform and populate my Ansible inventory automatically, so that I can sort of seamlessly work through this whole deployment with, like, the click of a button, essentially. So to show you how this works, I can go over to Ansible, and by passing it the playbook path and my inventory file, actually what I'm going to do, in the interest of time, I've already set up these Ubuntu machines and installed PM2 and such. So I'm not going to run those tasks. That's just kind of boring in the output. So I'm just going to show running this application, and we'll just walk through these steps. So first, we're installing the dependencies on Nginx. We're copying our UI files from the build directory. We're copying over the root certificate to interact with our database securely. And then we're copying our Node.js files for our application, installing our dependencies for this application, and then we are stopping and restarting our Node.js server. So there's no need to manually, SSH into these machines or SCP. We don't need to do any crazy stuff from the command line or manage multiple internal wikis that inevitably don't get updated frequently enough by our development teams. We can just run a couple simple scripts in Terraform and Ansible. These are simple. Of course, they can be much more robust, and I'm sure some of you are deployment experts and are using these tools in much more exciting ways. But as we can see now, we are able to go to my application, and it is deployed, it is running. It's actually a little bit slow right now on the initial page load because our database pools on the Node.js server, I haven't implemented any way to warm up the database pools. So the first connection to the database will be a little bit slow, but then subsequent connections, once the pool has been populated, will be faster. So this is an application that I've developed trying to show a global deployment on a 3D globe using a library called React Globe, which is, a wrapper on top of WebGL essentially. And we're able to show doctors and patients and their medical records being sent to a particular region. So let's say that a particular doctor in India is seeing let's see, myself, and I'm from the UK in this case, and I come in with a headache on my visit days today, and they tell me, just get out of here. You don't need any prescriptions. So then when I am visiting this doctor, because I reside in the UK, my data needs to be sent to the database node in the UK. So this is just a really simple geo-partitioning data compliance application that I'm still working on. I thought it was more interesting to show you something that's actually real, that I'm adding features to and working on in real time, rather than just showing you some simple to-do list application, or at least I hoped so. We have a little bit of time, so I just wanted to show one more application that I've developed that's a little bit more full-featured, to give you a bit more of an idea of a truly global application, although with a similar infrastructure to what we just deployed. So I've created this global bookstore or retailer called, it's hosted at thelargestriver.com, which is loosely protected, but the largest river, it's Amazon. It's just a corny way of recreating Amazon.com. So by choosing a phone location, we can select where our traffic will originate from. So let's say that we want to have our traffic coming from London. So I've created this application that is showing a bunch of products. We see some tech products as well as books eventually as well, because Amazon originated as a bookstore. So as we can see here, we have multiple database deployments, and from London, we're seeing latency of about 146 milliseconds when connecting to a single region cluster that is in the United States. So when we were talking through that original example, this is it exactly, where we have a 3-node cluster in the United States. Maybe this is resilient. It's remaining available if one of our availability zones were to have an outage, but we're still experiencing very high latency. So in order to combat this, we could change our cluster deployment to actually have read replicas in faraway regions where we're seeing a bunch of traffic. And in this case, we're putting a replica node nearby in Manchester, and we're seeing latency of only 4 milliseconds on this cluster. So by adding read replicas, we're able to reduce latency as well as spread the load globally. And as I mentioned, these clusters can all be tuned in different ways to be replicated synchronously, asynchronously. You can set up hooks in the database such that when you write to the database, you can actually use a change data capture feature to ping an endpoint somewhere, to set up, to kick off some sort of analytics processing. There are all sorts of features built into our databases that, maybe this is obvious to many of you, but it didn't really occur to me prior to starting this job, a year and a half ago. I thought of databases more so as just, this is where we're persisting our data and this is the way it is. But there are a lot more features that are becoming built into our databases that can be taken out of our application tier, and we can just let the database manage these things rather than needing to set up this infrastructure ourselves or solve some of these engineering problems that are already being solved from some of these managed services. So that's sort of the end of my presentation. I hope it was at least moderately interesting to some of you.
Yeah, you sold us like 4 milliseconds instead of 140, like 145. It's super cool. And as I understood, like you're working on this product on this database, distributed database. Are you Yugabyte database? Is a distributed database? And what is your company solving exactly this problem? Like just distribution across the globe.
Mm-hmm.
Is it?
Yeah. So it's I'm trying to give customer use cases that are publicly available. So like, for instance, we work with a number of financial services customers and as well as major retailers. I'm not just saying this because I work for the company. Like, I'm not just here to like shill my company or something like that. There are a number of distributed databases on the market.
Yeah.
But it's pretty cool. Like the founders of the company were some of the core members of the team that developed Apache Cassandra.
Cool.
They were working at Facebook, and they've been working in the database world for decades now. Many of them originating at Oracle, then working at Facebook, and then they started YugabyteDB not too many years ago, but they were working in stealth mode for a bit. So, for instance, Walmart uses our database with a massive cluster that's able to withstand queries to their product catalog for peak season in the holiday time. So everything is being kept in sync. They're able to fail over to additional nodes, load balance. We have database drivers that are, I'm sure many of you are aware of, like JDBC or other clients or drivers for whatever programming language that you like coding in. But we have native drivers that allow you to, they're smart drivers. So they're aware of the topology of your cluster, and they can actually load balance your requests either regionally or globally. You can tune it however you would like, so that directly from your application, you can load balance your requests to the database nodes themselves. You don't need to use some external service for like service discovery or something like that. So yeah, financial services as well. We work with Wells Fargo and Charles Schwab and like a number of very big name customers that essentially they're trying to solve huge problems with regards to like, our application cannot go down under any circumstances. It's not just about latency, but also these customers want to be able to run on multiple clouds in multiple regions. They're covering every single one of their bases to make sure that they have absolutely no downtime in their applications, and they're able to upgrade without a single worry in the world. They can just decommission certain parts of their application and do a rolling upgrade of their data tier with just without even thinking. Really, it's pretty cool.
Awesome. Thanks a lot for sharing all of this stuff.
Sure.
Do you have any questions like for our presenter today?
I have a question about the Terraform that you were showing.
Sure.
I noticed you were deploying to GCP, but you also mentioned earlier in the talk around having a multi-cloud support. How might using Terraform be able to do multi-cloud when it seems like in your example there was some cloud-specific terminology used there?
Yeah, I wonder. I do. I mean, I can only surmise. I can't say that I've actually deployed to multiple providers. Like I typically I've only used Azure and AWS deployments for like specific projects where I wasn't managing the infrastructure, but I believe that it would be quite simple in that you can just set up output variables for these various services that you're provisioning, infrastructure that you're provisioning. So Google has a Terraform provider. Like you can sort of go on the Terraform website and search for any of these major cloud providers, and you will find a provider with a whole set of configuration options. Like I'm just setting up a fairly bare bones application here, but you can use it to set up all sorts of services. I mean, you're aware of how many services that these cloud providers are enabling for us, and there are dozens coming out every month, seemingly. Like we're all in over our eyeballs with these services. So I think you could just make additional configuration blocks in your main Terraform file and deploy code to them just the same. And I think honestly in Ansible, so long as you are deploying to the same types of instances, like say, you want to deploy only to Ubuntu machines or container optimized runtimes, you could potentially just not even need to care about the cloud provider at all on the Ansible side of things. So actually, maybe that's my next demo app. It's one of the cool things about my job that I'm absolutely loving is just begging the IT team to give me advanced privileges in a cloud provider, and I sort of have the ability to just spin up whatever I want as long as it's not costing too much money and I'm not being a jerk about running up a huge bill. So I look forward to using Google Kubernetes engine and a variety of other services, maybe even multi-cloud. I know Yugabyte just recently announced that we're able to deploy to Azure, which has been a huge undertaking along with the team at Microsoft. So now we're a 3-cloud, we have 3 public clouds, and you can deploy to your own private cloud. It's an open source database, so you're certainly able to check out the code. I think we have big name companies that you know of that are just running Yugabyte all by themselves, not paying us a dime, but yeah, go check it out, give it a look.
Yeah, awesome. Any other questions?
Yeah, I like this comment. Yeah, it does feel like a lot of our jobs are begging IT for elevated privileges, certainly. And I think we all understand why, because if everyone had elevated privileges, all of our companies would just go bankrupt with mistakes that are made in these.
Yeah, right.
But yeah, if anyone has any additional questions on anything or just wants to chat, just find me on LinkedIn or anywhere, join our developer community, or yeah, just ping me. I'm happy to chat about any of these things. And yeah, thank you to Yuri and everyone for allowing me to talk. I've come to the last couple of meetups and learned a lot myself, so I intend to keep coming back, and it's nice meeting all of you.
Thank you so much, Brett. It was amazing chat. Like moreover, like you almost like publicly promised about your next talk. We'll count on you.
Hey, I'm down for sure. Yeah, anything that can allow me to go build some stuff off on my own for a little while, and I'm happy. So just let me know.
Yeah, thanks a lot. And you covered actually like many problems that we are struggling like during last several years. Like, for example, like data residency, like how to achieve all of this stuff, like how to deal with this stuff. Because it looks like company right now globally is switching like to all of this like regulations. They need to follow different regulation in different countries. And even Brexit, for example, like UK went from like European Union. It creates a new region for everyone, because right now they're publishing a new law, like, and it should be in place in November. Like, it means like all UK data should be in UK, like not.
Oh, really?
Yeah, like, and it's quite interesting and quite hot topic in the industry. And of course, like availability, latency, it used to be always hot topics. Yeah, thanks a lot for coming. Thanks a lot for great presentation, and thank you everyone for joining today. See you next month.